Dear students, welcome to our class on Micrometeorology of Crops, Water, 5. So far, Micrometeorology of Crops, we have discussed in 4 chapters. Like the first 5 short videos were on solar radiation, next 5 were on temperature, third 5 were on wind, and the fourth one is on water. Now today we are completing water, micrometeorology of the crops. Okay, here in this class we are going to understand very interesting, very basically it is the work of the micrometeorologist and the agrometeorologist, that is agricultural uses of occult precipitation. Agricultural uses of occult precipitation. This is the book. This is the book of a wonderful scientist by name. See here. Okay, he is Andres Acosta Belladon. Andres Acosta Belladon. Okay. Now this was the fund. This is Agrometeorological Applications Associations, France, OMEX, France. This is funded by Food and Agriculture Organization, Rome, CTA, of course, Joint Research Center, European Union, and World Meteorological Organization. So, a combination of 4 international UN agencies have helped in bringing out this wonderful book, but extraordinary work done by Dr. Andres. Now, here in this class, we are going to understand what is occult precipitation. Okay, how it is related to water. First, we go for definition of it. Then advantage of dew, disadvantage of dew, fog, conditions for fog, smog, uses of fog and RH applications. With reference to application, I am going to discuss with you only 2. One is grapevine, the second one is the apple. Okay, apple example. See here, what is occult precipitation? See, it is before I read the definition, straightforward rain is there, it is useful to the crops. However, the forms of condensation or sometimes even precipitation which cannot be measured by standard rain gauges, we call it as occult precipitation. Of them, most important is dew, second one is the fog, of course smog is there, then to some extent frost we cover in the later classes. Here they have got a lot of significance with reference to maintenance of soil moisture and also the vegetation and its development. Okay, in areas where there is a stress and strain of a moisture or deficit. Now let us see the definition of it. The definition of occult precipitation is the supply of water to the soil or vegetation. The supply of water to the soil or vegetation, not by way of straightforward rain, not measured by convectional rain gauges. This is what I told. Now, what are the different things we have discussed in the last class? What is dew point extensively. Here in this class, I would like to share with you first very general statement like this. In tropical and subtropical regions, with low rainfall but close to seas, rivers and lakes, the high daytime temperatures cause high evaporation. The daytime temperatures of high, they cause more evaporation and water vapor remain in the ambient air. During night, when the temperatures decrease, condensation occurs, covering the crops with dew or fog. 3 conditions are there. First condition is they are the low rainfall areas but closer to oceans, rivers or lakes. Again, during the daytime, lot of evaporation occurs from these water bodies. Water vapor enters into the ambient air. Okay. Night time, when the temperatures are coming down, the water vapor condenses either in the form of dew or in the form of dew or fog. Okay, this is what. Here, as I said in the previous class, a bit will come. Cold, dry air is heavier than the warm, or you can say hot, to some extent moisture. So this is the principle involved here. Now, see, usually dew maximum 50 mm in a calendar year or an agriculture year, usually across the globe. Now, some lower species of crops, they survive very good on the dew. Some crops like prosopis, higher crops like even eucalyptus, they survive on dew. Okay, both lower and higher crops, okay, or plants. Crops like cereals. In this book, extensive work was done by Dr. Andreas. In this book, it was also mentioned that crops like, just hold your breath, crops like wheat, crops like cereals, all cereals for that matter, some orchard crops, some vegetable crops like tomatoes, they all grow to a greater extent even though the rainfall is around 250 mm in a year. 250 mm in a year. Why? It is because in those areas the soil conditions, the relief, and other conditions with reference to water vapor present in the atmosphere play an important role for these things, that is in the form of either dew or fog. Okay, this is what. So what are the advantages of dew? I have already mentioned in my 1 or 2 previous classes when we were discussing water 1, 2, 3, 4 like this. Here the advantage of dew is it gives some crops like Bengal gram, we call it as chickpea, okay, worldwide we call it as there it responds extensively, very good for the dew or fog. Okay, number 1. 2, most of the cereals that are grown in the low rainfall areas, so they respond very well. Similarly, as I told half a minute back, vegetable crops like tomatoes or potatoes for that matter, which require on an average around 400 mm, even though the rainfall is around 250 mm because of this occult precipitation. Okay, precipitation which is not measured by traditional rain gauges. Okay, occult, they give good crop yields. This is what. So what are the disadvantages? Disadvantages of dew are whenever dew occurs, please observe in your areas also, sclerotium, or you can say any mildews, they are the most common when dew or fog occurs. These are the disadvantages. Even in case of animals, so when this was mentioned in this book, when animals were fed alfalfa with dew, okay, which was dew subjected forage crop, they developed some sort of diseases because of which some gas, enormous amount of gas, and then through a puncture technique, gas is removed from the animal. That was also mentioned. This is the disadvantage, but advantages are more. So fog. So what is fog? Fog is one of the forms of condensation. Okay, one of the forms of condensation. What are the forms of precipitation? Liquid forms, rain, drizzle, shower. Mixed solid forms, hail, snow. Okay, the mixed forms, sleet and glaze. So what are the different forms of condensation? The first one is the dew. Second one we always talk about agriculture. For agriculture applications, this is what, okay, agricultural uses of occult precipitation. Second one is the dew, we call it as second one is the first one is the dew, second one is the fog. What is the fog? Meteorologists define fog as the condition in the lower part of the atmosphere where the visibility is up to 1 kilometer, where the visibility is reduced from 1 to 5 kilometers, we call it as the haze by definition of meteorologists. From agricultural meteorological point of view, what we say is that fog is defined excellent with reference to the reduction in the visibility. However, fog in terms of the availability of RH and the temperature, the relation between the temperature and RH play an important role with reference to the fog, which helps water supply to okay, which supplies the water supply, okay, supply water to the crops and also soil. From that point of view, okay, fog, smog is the one when smoke is added from the industries, Fog plus smoke is smog, okay, that we know it. So it causes a lot of respiratory problems, some uneasy conditions in that one. Now, here I would like to discuss with you the most, after the definition of fog, the conditions for fog. Here, the conditions for fog and dew are almost same, slightly different. What is the major difference between the fog and dew? Dew is first, we cannot see the water vapor in both the cases. We cannot see. First, in the initial conditions, but when it is forming on the leaves, we can see the dew. Similarly, late in the evening, okay, fog starts forming up to early morning, 1 or 2, 3 hours in the morning. There, which we cannot see water vapor, we can see water vapor, okay, in the condensed form. Okay, that's what. So the difference is dew falls either on the soil or on the vegetation. Fog also falls, but in the lower part of the atmosphere you can see it. That's why meteorologists have defined it in terms of reduction in the visibility. Now, so the conditions for fog are also same as that of dew, which we discussed in the water 5. Water 4 we discussed in the earlier class. Okay, heating during the day, clear sky, light wind less than 3 meters per second, and thermal inversion, high RH, relatively high RH. So these are the conditions. Actually, the fog occurs more on the land surfaces as compared to water surface. Even on the water surface there is a fog, advection fog, radiation fog, whatnot. So many fogs that I have discussed in the Introductory Agronomy Climate Change. Now here I would like to enlighten you that usually fog forms during the night and also during the early morning, what I told a half minute back, when hot and humid air mass flows over a relatively cold surface, advection fog occurs. Okay, two things, air masses. Hot and humid air mass flows over a relatively cold surface. Adiabatic cooling of air, when it moves upward over slope, leads to condensation and orographic fog is formed. We find over the hilly areas orographic fog. How it is formed? Adiabatic cooling of air when it moves upward. Adiabatic cooling when it moves upward, okay, over a slope leads to condensation. Okay, condensation, when it is going up, condensation occurs and orographic fog is formed. Of course, there is a katabatic fog. It is formed when cold air descends. Okay, along the mountain slope towards the valley bottom. Okay, that is exactly reverse of the this orographic fog, and this is a katabatic fog. And another important thing is that fog can be formed by water evaporating from rivers. That's what I told in the first statement. Water from rivers, lakes, or say nearby oceanic areas. Of course, when water is transferred by vegetation into the cool air also. Here, this is very interesting. Water is transferred by vegetation in forest areas, Mediterranean areas, for example. Water released by the transpiration by the vegetation. This is what I would like to say, and which facilitates its condensation. Finally, it is very characteristic over rivers, valleys, lakes, and also sometimes behind the dams where water is there. Okay, multi-purpose dams we construct. Okay, this is one. Now, the uses of fog and RHA, and these are the things that I have discussed several times. However, the fog moves up against the slope of the hill. Okay, it will leave water on the objects on its way more than 10 centimeters, that means grass, okay, more than 10 centimeters when it is moving. So this is what is important for our agriculture, okay. Fog intercepts, okay, vegetation intercepts the fog and get the moisture. This is one advantage. The presence of vegetation enhances the capture of water. This in the applications, farmer. Now in today's class, just for 1 or 2 minutes, I am going to discuss with you this grapevine and this apple example. In addition to that, I am going to cover in the farmers, okay, in our please subscribe to our channel, Agronomy Farmers and Rural Development. There in the playlist of farmers, I am going to give more information on this interception examples also. Pest and disease assessment and control. Of course, this helps. Mildew, cercospora, rust. Mildew on grapevines. Temperature 22 degrees centigrade, RH 70%. Cercospora on sugar beet, temperature 28, RH 90%. Rust on wheat, temperature 20 degrees, RH 95%. So RH, fog or dew, anything we can take it here. Now, so here the interesting two examples I would like to discuss with you are just last half minute or 1 minute of the class. Here in this book, first I will tell, in this book you cannot see, this is the Agriculture Uses of Occult Precipitation by Dr. Andres N. Acosta Belladon. Okay, here he had given wonderful photographs, he had given on two. That number one is the grapes, how the grapes are grown with occult precipitation. Grapes, this is what, yeah, this is the what, this is the grape, you see. This grape is grown in 4 meters length, 1.2 to 2 meters width, small trenches. Okay, 4 meters length, 1.2 to 2 meters width trenches. See, if we see it here. Now, so what is the depth? The depth mentioned also here. 3 into 4 meters diameter, 1.5 to 2 meters deep. 1.5 to 2 meters deep trenches, grapevines are grown. How these grapevines will grow? Very interesting. When wind moves, wind has water vapor which cannot be seen by our eyes. However, when it is passing and when it is cool and dry air is passing over these trenches of 1.5 to 2 meters deep and 3 into 4, okay, width and length, the cold air drains into the this particular trench. So dew is deposited because cold and dry air, heavier, so it goes into the holes and then our trenches, and then it gets wonderful occult precipitation. The second one is the apple. It may not be seen by you, but still I would like to show you. This is a apple grown in area where 250 mm rainfall annually. Around this grape there are stone walls. So exactly reverse of what we studied with reference to grapevine. Grapevine in the trenches here to 2.5 into 1.5 into 2 meters deep. Trenches are there like this. Okay. Now width is 3, length is 4 m. Now exactly reverse, same size as above the ground in case of particular apple. So winds are stopped, winds are obstructed, and they go up. They again enter into the trench above the ground. In addition to that, solar radiation, when in the morning falls on the western side of the wall, it reflects, and in the evening on the eastern side of the wall it falls, and then during the cold, very cold time, okay, the trunk and then the crop is protected, the apple crop is protected. These are the applications of occult precipitation. Thanking you for your very patient hearing.